Generally, a conditioning system is a type of mechanical system designed to regulate and maintain the indoor environmental condition within specific conditions such as temperature in a space, quality of air, humidity, and the flow of air to provide a healthy indoor atmosphere, and thermal comfort following the heating, ventilation, and air conditioning system. It usually consists of few components such as condenser, evaporators, compressor, chiller, fans, ductwork, and thermostat which act as the control mechanism. The air conditioning system is one of the major and significant components in building service, whether large or small, for the purpose of ensuring comfort for users in each space. For your information, in educational institutions such as UITM Samarkand Campus 2, the air conditioning system plays a very important role in providing a conducive environment for the session and official activities through the effectiveness of the system. One of these is Bilik Seminar Utama, which is always in use by the community of UITM for lecture, meeting, and big events. This makes the Bilik Seminar Utama need an air conditioning system that will be able to maintain the appropriate temperature and quality of air within the room for the comfort of attendants. This report is intended to explore the type of air conditioning system in Bilik Seminar Utama UITM Samarkand Campus 2. Besides that, this report also looks at the component involvement in the system, the operation of the system, and its effectiveness. Moving on to the background of Keston. University Technology Samarkand Campus 2 is in Kota Samarkand, Sarawak. It is also one of the campus equipped with various modern facilities to meet the needs of learning and activities of the student, and among them was Bilik Seminar Utama. Bilik Seminar Utama was built in a strategic position to accommodate so many people within it, providing an opportunity for conducting lecture sessions, seminars, and official meetings within the campus setting. Since there are so many users and the place is enclosed, it should have an air conditioning system installed to create a comfortable internal temperature, especially for a hot and humid area like Sarawak. These researchers will study the type of air conditioning system, use their installation method, and their primary components. This report will further discuss how the air conditioning system works in Bilik Seminar Utama.
Now let's get into the types of system. Before I want to explain anything, I want to show you guys a diagram of the Bilik Seminar Utama floor plan, also the air conditioning layout. Now let's get back into the topic. Our most recent case study shows that Bilik Seminar Utama, or also known as BSU, uses split unit as a part of its unitary structure. As the heart of the building circulation system, the split units, air conditioner, also known as the heating, ventilation, and air conditioning system, HVAC, consists of the internal units that can be composed of fan coils, or also known as FCU, for its multi-room system, and air handling units, AHU. This is because AHU, just like a heart, it pumps clean oxygenated blood via the arterial system, pulsing warm, oxygenated, and clean air to the building's room. Aside from that, the building features a centralized plant system which circulates cold air via a system of supply and return ducts. Is one of the more popular solutions for this scale of building. Three real engineers indicates, for instance, show that the adjustability in each segment, user, terminal, refrigeration equipment, and distribution system would significantly affect the energy consumption and system efficiency when centralized air conditioning system is used. Because this kind of system is being used, it will be necessary to have like an interior unit with the heat exchanger and blower, and an outside unit with the composer, fan, and heat exchanger.
Next is the installation and components of the system. The air conditioning system requires good installation for it to operate well. Therefore, it is crucial to make sure that the installation process is done with extra care and following the right steps. During our case study in Bilik Seminar Utama ESU, UITM, Sarawak Branch, Samaran Campus 2, we found out that the room used these three systems, which is the unitary system split unit, plant system centralized plant system, and also multi-room system or fan coil unit. This is the process of the installation of the air conditioning system. First is to design and plan the system, which in this process you will have to calculate the load, selecting the suitable equipment and designing the system layout. The systems need to be planned carefully to make sure that the cool air was distributed uniformly to the whole space. Number 2 is site preparation. In everything we need to prepare a site, which is like the space inspection, because it needs to be done to confirm the suitable space for the ducting, vents, and other units of the air conditioner. Ensure that the electrical supply such as voltage and amperage are suitable for the system. During the site preparation, structural modification or new built structures should also be done during this process. For example, ducting work, creating openings for the air handlers or refrigerant piping. Number 3, installation of air handling unit AHU. The installation of the AHU need to be installed at the planned position. Like if we refer to the first step, we have planned it, so we have to install it following the things that we have been planned. This is to ensure that the leveling is proper and the mounting is secure. Number 4 is the installation of outdoor unit. The outdoor unit should be placed outdoor, such as condenser or chiller on a concrete pad or a mounting brackets. Number 5 is the installation of ductwork. During the installation of ductwork, ensure that the site is proper and make sure to avoid the turning corners from being too sharp, as that may create kinks that will restrict the airflow. Number 6 is the installation of piping and wiring. The refrigerant pipes and drain pipes and also electrical connection between the indoor and outdoor unit are connected during this process. Moving on to step number 7 is to set up the control system. Thermostat and control panels were installed so that the air conditioner could be controlled from a certain distance. During this process, the system will program for automated cooling, temperature control, and zoning if required. After that is the installation of insulation. It is important for insulation to be installed, especially to the pipes and the ducts, so that the energy loss could be reduced. Ensure that the installation of insulation need to meet the local building codes and standards. Next is step 9, which is testing and balancing. Tests such as pressure testing were done to test the refrigerant line leaking using a vacuum pump and nitrogen. Air balancing is also being done to test the airflow at each vent and balance the system for uniform cooling. After that is commissioning at step 10. The system was started to check its performance. This includes the cooling efficiency, thermostat control, and also the distribution of airflow. Any adjustment is being done during this process. Now, let's talk about the components of the system. The component that is used is number 1, cooling tower fan. The cooling tower fan functions to draw in air from the bottom and expels it upwards, counteracting the warm condenser water at top of the unit. Number 2 is water tank. Water tank is mainly used for storing water that will be used for many purposes such as drinking water, farming, cooking, and more. In this case, the water tank is used to store water to be used for cooling in the air conditioning system. condenser water pump is a medium that is used to circulate the cooling water between the chiller and water cooled condenser and cooling tower. Number 4 is chiller. Chiller is used to lower the temperature of water for the circulation process in the air conditioning system or HVAC, which is the heating, ventilation and air conditioning system, to provide thermal comfort. Number 5 is chilled water pump. Chilled water pump is used in the HVAC system as the purpose is to circulate chilled water through the pipe system and heat exchangers. Number 6 is the FCU, which is the fan coil unit. Fan coil unit is a component that is used to transfer heat or breeze without the need for ductwork. Number 7 is ducting. Ducting is a type of piping system that moves the air, gas, liquid or wire from a place to another places. Mainly, it was used for ventilation, heating and also air conditioning. Number 8 is pipes. Air conditioner piping is a system that carries refrigerant and water away from an air conditioner. Some example for air conditioning piping is copper pipes and water drain pipes. Number 9 is evaporator. The evaporator functions in contrast to the condenser. Here, refrigerant liquid is transformed into gas, absorbing the heat in the air in the compartment. From the air in the compartment. Next is number 10, expansion valve. An expansion valve is a device that regulates the flow and the pressure of refrigerant within the system. It is commonly utilized in air conditioning and refrigeration system. Last but not least is the compressor. An air conditioning compressor is a mechanical device used in systems such as a central heating and cooling or split air conditioner. It works by converting low pressure gas into high temperature refrigerant, which helps regulate the temperature in the building. Now I have done my part, I will give the slide to Khairunisa.
Now let's get into the operation of the system. Firstly, centralized plant system. Bilik seminar utama is cooled by a central air conditioning system that uses a chemical refrigerant process controlled by an inside thermostat. In copper coils, one for indoor usage and one for outdoor use, the refrigerant alternately evaporates the condensed. The interior evaporation part of this process gathers heat from the room, while the outdoor condensation part releases it. This cycle cools the interior coil by pulling warm air from the room and passing it over when the air gets cooled down. A system of vents and ducts is then used to distribute this cool air throughout the room. In a centralized air conditioning system, the process of cooling and dehumidifying the air involves several steps. First, when the thermostat detects that the air temperature is too high, it activates the system. The interior fan then pulls warm air through the written air ducts. As the air passes through filters, dust and particles are removed. The air travels over the evaporator coil, where the refrigerant absorbs heat and turns into a gas. The cooled air is then pushed into the room through the ducts by the blower fan. Meanwhile, the refrigerant gas is pressurized by the compressor and sent to the condenser coil, where it transforms back to a liquid, releasing heat outdoors. The cycle then repeats as the refrigerant returns to the evaporator coil, continuing the process of cooling and dehumidifying the air in your home. Secondly, the split units. The two units that make up the split air conditioner are connected by electrical wire and refrigerant unit. The outside unit cools and circulates cold air into the inside unit, while the indoor unit absorbs heat. In the split air conditioner, the process of removing heat from the air involves circulating refrigerant gas through a cooling circuit in a series of steps. First, the interior unit takes in the warm air from the room. This air passes over the evaporator coil, which contains low temperature refrigerant. As the refrigerant absorbs the heat from the air is cooled. The non-cool air is then recirculated back into the room. Next, the heated refrigerant moves to the outer unit, where the compressor increases its temperature, turning it into hot high pressure gas. The refrigerant then flows through the condenser coil where it releases heat into the outside air. Finally, the refrigerant, now cooled and in released liquid form, returns to the indoor unit and the cycle repeats to continuously cool the room. Lastly, fan coil unit FCU. A fan coil unit FCU is a device that uses a fan and a heat exchanger to heat or cool the air in space. FCU are a component of HVAC systems found in commercial, industrial, and residential buildings. In a fan coil unit FCU, the process begins when the fan blows air into the unit. The air then passes through a heat exchanger where it either absorbs or releases heat, depending on whether cooling or heating is needed. The temperature of air is adjusted accordingly. Finally, the heated or cooled air is released into a room, helping to maintain the desired room temperature.
Now let's get into the advantages and disadvantages. For my part, I'll be explaining more about centralized plant system. For its advantages, generally the centralized air conditioning system works efficiently for big halls because it maintains a balanced temperature over several rooms or floors for comfortable conditions in the whole space. It is easily controlled from one location, allowing various temperatures to be set for each room or zone, therefore giving flexibility and convenience in terms of not needing to manually control each separate unit. Other than that, centralized air conditioning systems are usually sleek and modern in appearance, which easily blends with the overall aesthetic of the room. It is also space saving since it does not require separate units for each room. Then I'm going to talk about the disadvantages of using a centralized plant system. Initial maintenance costs for a centralized air conditioning system can be extremely high considering professional installation and service. These are usually put back into energy efficiency and long-term benefits of the system. Other than that, this system can be a bit noisy at times, especially if the unit or the ducts are not well serviced. And this disturbance upset many people, especially in quieter environments or at night when the levels of noise are more apparent. Lastly, the centralized air conditioning system is complex in installation and may require a professional to do the installation properly. The system includes intensive ductwork and connection that may not be suitable for every type of building.
Now I want to explain about the split unit air conditioning system. The advantages is it has variety of selection in terms of size, color and design. So there's a wide variation in these three terms. Hence, there is a model for every space, from a small unit located in a compact room to a larger or a more spacious area. Number 2, it has quiet operation. Most of the noise generated by this system is produced by the outdoor unit. Some models are ultra quiet, hence suitable for bedroom, offices or any area that is sensitive to noise. Number 3, it is inexpensive to operate. These systems are relatively cheap to operate, and cooling a medium-sized room often only costs 25 to 35 cents per hour, so that they are reasonable price to run all the time. Now I want to talk about the disadvantages of using split unit system. Number 1, the outdoor noise compressor. The outdoor compressor might be noisy, and this can be especially valid when it is not well serviced. It might concern those who live in a quieter area or noise sensitive. Number 2, the space for the outdoor unit. I'm saying this because the outside unit needs space for its installation, which may not be possible for houses with small space and on the balcony or in the yard, hence complicating the installation process in such properties. Last but not least, it is more expensive to install because it has a lot of variation. So some of it will be cheap and some of it will be expensive. So in this term, I want to talk about the installation can be more expensive if the indoor and outdoor rooms are installed farther from each other. The It requires more materials or longer piping, making the installation process to be a bit more complex. Now, I want to pass the slide to Khairunisa.
The last one is fan configured FCU. As for the advantage, FCUs offers temperature control in each room or zone individually, allowing the occupants to adjust the temperature according to their preference and comfort level, keeping each space at the ideal temperature. The system is structured in such a way that air conditioning occurs in only those rooms where people are present to utilize it, rather than letting energy go to waste in unoccupied areas for overall efficiency. Since FCUs focus on cooling or heating areas that are utilized, it can be cost-effective in the long run, as there will be no unnecessary cooling or heating of entire buildings, thereby making FCUs an economically viable and ecologically sensitive option.
Now we have come to the conclusion of our presentation. The centralized air conditioning system installed in bilik seminar utama that UiTM Samaran conducts to has therefore been effective in maintaining an internal environment within a comfortable range to allow a user to carry out activities such as a lecture and meetings. This is evident now how the use of centralized air conditioning in a space can maintain a constant and appropriate indoor temperature, thus assuring comfort even when the number of people present is large. The result of this report indicates that the centralized air conditioning system fulfills its functional requirement, especially in terms of cool air distribution within the seminar room. Moreover, the application of centralized air conditioning has proven that with appropriate design and space capacity, it can serve big buildings like bilik seminar utama and UiTM Samaran campus. In short, a centralized air conditioning system is an essential element in comfort and effectiveness in terms of various activities such as lectures and meetings that will be conducted in bilik seminar.
Now we have reached at the end of the presentation. Thank you for your time and we'll see you in the next time.
Bye.